representation of electrode potential. First is metal electrode. So for example, if we have Zn solid it will go for reaction Zn2 plus 2 electron, and you can say this is aqueous. So how you represent this reaction? So you know that E. So first you have to write the solid and you have to give the vertical line. Vertical line represent phase change, and then Zn2 plus aqueous. No need to represent the electron. Clear? So any oxidation process, any metal undergoing the oxidation, you have to write like this. Clear? For example, if manganese solid Mn2 plus aqueous plus 2 electrons. So how we represent? E Mn solid to Mn2 plus aqueous. Yes or no? So write down. So this is the at anode, or you can say oxidation process. So at anode oxidation occurs, that is the loss of electron, and at that time you have to represent like this. First solid metal will come, then aqueous metal, that is the ion of that metal. Reaction occurs like this: copper 2 plus aqueous plus 2 electron, it will form copper solid. So how we represent this cell? So it is represented as Cu2 plus aqueous and Cu solid. So this is called what? Anode or cathode? Cathode. We have Ag plus 1 plus aqueous 1 electron, it will convert in Ag solid. So how you represent this electrode?
Ag plus straight line AGS.
E Ag plus, you have to write their phase, then you have to give the vertical line for distinguish the phase, and then Ag solid. So next is hydrogen peroxide. Here oxygen has -1 and here oxygen has -2. So you have to balance the charge, and before this you have to balance the atom which oxygen state is going to change. So here 2 oxygen atom, here 1 oxygen, so you have to multiply by 2. Now balance the electron. So from 1 atom of oxygen is undergoing -1 to -2. So how many electron is required? So to become from -1 to -2, 1 electron is required. And how many atom? 2. It means 2 electron is required. And at last you have to balance the hydrogen. So how many hydrogen here? 2 hydrogen. Here 4 hydrogen. It means you have to add here 2 H plus. So this is the balanced chemical reaction. So first balance that atom which are undergoing to change the oxygen state. So oxygen state of oxygen has -1 here. So for -1 to 0, how many loss of electron? For 1 atom? 1. So for 2 loss of electron. Now balance the hydrogen. So how many hydrogen? 2. If you represent this cell, so this is oxidation or this is reduction, that is cathode. So how you write? E of H2O2 H2O. So H2O2 undergoing reduction process. So therefore you have to only mention that substance having oxidation number is changed, that is H2O2 having -1 and water having -2. No need to write the H plus here. And here also H2O2 is going to oxidize, therefore you have to write only H2O2 and oxygen, no need to write H plus. Redox electrode. So what is redox electrode? So any redox reaction, MnO4 minus undergoing Mn2 plus. So you have to write the cell representation for this reaction. So first of all, write the balance reaction. First find the oxidation state of manganese here. So what is the oxidation state? +7, and here +2. So from +7 to +2, how many electron is required? 5 electron. Now electron are balanced, charge is balanced here. Now you have to balance the other atom. So it has only oxygen atom. How many oxygen here? 4. So how you balance oxygen? By adding water. Which side? Right side? Opposite side? Yes. So how many water is required? 4 mole of water is required. So 4H2O. Now you have to balance the hydrogen. So how many hydrogen is required here? 8 H plus. Got it? So this is a balanced chemical reaction for MnO4 as a oxidizing agent. Clear? This process is called reduction. So now for reduction you have to write the cell representation for this electrode representation. So how you represent this? MnO4 minus, which is going to change Mn2 plus. For this Cr2O7 2 minus undergoing to Cr3 plus. So first of all balance H and represent. First of all you have to identify which atom has different oxidation state or which is going to change the oxidation state. So here there is no oxygen, so no need to check oxygen. So chromium has +6 and here chromium has +3. So from +6 to +3, how many electrons are required? 3 electrons. But it has not only one atom, it has 2 atoms. So first balance that atom which is undergoing to change. Now balance the electron. So for one atom from 6 to 3, 3 electron is required. Therefore for 2 atom 6 electron is required. So you have to balance, write down here 6 electron. Now you have to balance the oxygen. So how many oxygen here? 7 oxygen. You have to add 7 mole of water, and now you have to balance the hydrogen, which will be 14 H plus. Now this reaction is a balanced chemical reaction, balanced half cell for the redox reaction. Now how you represent this? E of Cr2O7 2 minus Cr3 plus. Got it? Good. And the last, write down metal insoluble electron reduction. reduction. So we have AgCl solid. Reduction means gain of electron. It will accept one electron and it will form Ag solid plus Cl minus aqueous. Now how you write the cell for this? AgCl solid. Ag solid. Yes or no? Wrong. You have to also write Cl minus aqueous. So next is oxidation. Yes.
But if Cl would have been in solid state only, then we would have not written it, right?
Oxidation means loss of electron. So here Cl minus aqueous, it will form AgCl solid, and it is oxidation, therefore loss of one electron. Now you are going to represent this. So how you represent? Ag solid, AgCl not aqueous, it is solid, precipitate, and then Cl minus aqueous.
But we should.
So in this Cl minus is required always, and it is the aqueous phase, therefore you have to write the